Welcome back to Concepts in Arithmetic. In this video we are going to talk about some methods for doing mental math. We've mentioned several of these in previous videos, so this is going to be like a consolidation thing where we summarize everything. We are going to add a couple new things. But the first method for mental math that we're going to talk about is rearranging. So rearranging involves using the commutative property and the associative property, sometimes even the distributive property, to give us an easier problem. So let's look at this example right here. So 17 plus 59 plus 23. Okay, well, if I were to add these two numbers, of course you can do it, but I have to do some carrying. So it's actually much easier to add the 17 and the 23 first. So 17 plus 23 gives me 40. And now this is a one-digit place value problem here, so I got 99. Okay, so that rearrangement allows me to handle these two first, making the problem easier. Down here, okay, 5 times 17. Once again, we could do that problem. It involves carrying, so it's a little tougher to do mentally. It's better to do the 5 times the 2 first to get a 10. Now you do 17 times 10, and you've got 170. Okay, this is a little bit trickier here. 257, so 250 plus 7 times 4. Now the point is that 4 times 250, that is an even 1,000. 7 times 4 is 28, so you have 1,028 there. Okay, so this, I believe, is the first example I've shown in any of these videos of using the distributive property here. We're going to see a couple more examples like that, but this strategy does build on this other strategy. So when you're looking to rearrange to make something simpler, you have to be able to spot these compatible numbers. Okay, like up here, 5 and 2 are what we might call compatible numbers because 5 times 2 makes 10. Very easy to multiply by 10 in the place value system. So similar thing right here. 25 and 4, those are compatible numbers. We're going to multiply those first. 25 times 4 is 100, so we have 38 times 100, so 3,800, or some people might even just say 3,800. Down here, 86 plus 174 plus 14. If we notice that the 86 and the 14 combine together to give us 100, we know, okay, we should do a rearrangement and add those two first. So effective use of rearrangement is predicated upon being able to use compatible numbers. You have to spot things that combine to multiples of 10, spot things that combine to 100, stuff like that. So when we're doing mental math, we often do rearrangements, but we can't do rearrangements until we have a good grasp of compatible numbers. This is something that we have discussed in several problems here. Compensation, and that is converting the problem to an easier version that has the same answer. Okay, so 97 plus 38. You can add it using the standard pencil and paper algorithm, but it involves carrying, which is difficult to do mentally. So what we do is, okay, 97 is close to 100. We'll take 3 from the 38 and move it over there. So this problem is equivalent to 100 plus 35. And that, of course, is an easy one to do using place value properties, 135. I'm going to skip this one for right now. I'm going to come right back to it, though. Let's go down to this one. We're subtracting 19. Okay, the way I do that, I subtract 20 and then throw 1 back. Okay, instead of subtracting 19, we subtract 20, which is an easy place value problem. So 48 minus 20 is 28. You throw 1 back, you got 29. Okay, I might handle this problem like this. 27 times 4. Okay, well this is going to be a pain in the butt. I can do it. I'd have to do carrying. But remember, the whole point of mental math is to avoid carrying and borrowing and stuff like that. Okay, so 27 times 4, well 25 times 4, that's pretty easy. That's 100. But 25 times 4 isn't what we wanted. We wanted 2 more copies of 4. We wanted 27 copies of 4. So we'll take 25 of them to get us to an even 100, and then we'll deal with 2 more copies of 4, getting us to 108. Okay. When you're doing mental math, often left to right calculations can be easier than the standard pencil and paper algorithm, which goes the other way. Let me just give you a quick example right here where a left to right calculation might be an easier problem. Let's do something like 3 times, I don't know, 506. Okay, the standard pencil and paper algorithm would go like this: 506 times 3. 3 times that is 8, carry the 1, 3 to 0, that's a 1, and then 15. Okay, well, 3 times 500, that's easy because it's a multiple of 100. 3 times 6. 3 times 500 is 1500, and then that's an 18, so 1518. Okay, so working left to right is actually easier than the standard pencil and paper algorithm. There's no carrying or anything like that. So that can be handy, especially if you're multiplying by something small here, and there's not much of a chance you're going to have to do a lot of carrying. Okay, we have discussed in a previous video strategies for multiplying and dividing by particular numbers, 2, 4, and 8. If you're multiplying by 2, you double. If you're multiplying by 4, you double twice. If you're multiplying by 8, you double 3 times. And if you're dividing, you do the opposite. What's the opposite of doubling? Cutting it in half. So divide by 2, you halve your number. Divide by 4, you halve twice. And divide by 8, you halve 3 times. If you're multiplying by 5, the kind of quick method that we saw, you can have and multiply by 10. Okay, so if you're multiplying by 5, you can take that number, cut it in half, then multiply the result by 10. You can also switch these steps, so you can multiply by 10 first and then cut in half if you need to. If you need to divide by 5, you do the opposite of this. Double and divide that new number by 10. Multiplying by 9, multiply by 10, and then subtract your number. And of course we remember from algebra, we're using this property right here. 9 times a number is equal to this right here, right? You remember combining like terms. If you do 10x minus x, that's 9x. Let's just do a quick example. 13 times 9. So we would do 10 times our number. 10 times 13 is 130. Subtract 13. Okay, you don't even have to worry about the hundreds place. Just do 30 minus 13. Okay, 30 minus 10 is 20. And then 20 minus 3 is 17, so 117. Okay. And let's just throw in an example for multiplying by 5 just for fun. $38 times 5. Cut that in half. 38 cut in half. Oh gosh, what is that, 19? Cut that in half and multiply by 10. 19 times 10, 190. Okay, let me think of a number that I can divide by 5. Okay, 120. We got to take that and divide by 5. Okay, double this, 240. And then we're going to take that and divide it by 10. Okay, so 24. So 120 divided by 5 is 24. Okay, just a couple more things here. Multiplying by 11. Multiply by 10, and then add your number. Multiply by 10 and then add your number. Oh, let's try this. 24 times 11. So you do 240. So we take 24 times 10 plus 24. 264. Okay. So because 9 and 10 are right next to our base for our place value system, we can use this technique to do some mental math here. And this is something we actually haven't talked about yet, but if you're multiplying by 25, look for factors of 4. Let me give you a quick example of what I mean. Let's say I wanted to do 36 times 25. Okay, this would be a pain in the butt using the standard pencil and paper algorithm. There'd be tons of carrying, you'd have to do a couple lines. But I want you to notice something. 36 is divisible by 4. Okay, 36 is 9 times 4. So instead of looking at this like 36 times 25, let's look at it like 9 times 4 times 25. Now the point here is 4 times 25, that's an even 100. So we do the 4 times 25 first. In other words, we use rearrangement, the very first technique we talked about, and compatible numbers, which was the second idea that we talked about, and combine those to get our result right there. Okay, so we have rearrangement, looking for compatible numbers, using compensation. What else? Am I forgetting anything else? Working left to right calculations. And then we had a list of some strategies that work for particular numbers. And they all revolve around the place value system. Okay, so mental math is a really good exercise for students to do that helps them learn the place value system.